Okay, so hi everyone. Today I would like to welcome everybody to, I believe, MCR3U functions. So today we're just gonna get ourselves introduced. Remember that we're using the McGraw-Hill Ryerson textbook, so you can find these online. There's an entire version of it. So without much to say, let's get straight into lesson one. So I'm using McGraw-Hill for mainly one reason. It's because there's a lot of review in McGraw-Hill. Nelson cuts straight to the cheese and talks about functions and stuff, which I think is a little bit too straight. Cause some of you do not have math for an entire semester, and you're forgetting stuff. And I mean, grade 10 math is not hard at all, so prepare for the jump. All right, so today we're gonna review about exponent laws. So we're gonna talk about the five different ones, even though you were probably only told, I believe, two, because they never talked about the power of a quotient and power of a product. So we're going to talk about exponent law for multiplication. So when we have, right here, when we have 3 to the power of 2 and 3 to the power of 4, let me see if I could get a laser. No, okay, that's fine. So when we have 3 to the power of 2 and 3 to the power of 4, that's basically like 3 times 3 times 3 times 3 times 3 times 3. Now, when we have multiplication, we can obviously add the exponent together. So 2 plus 4, that gives us 3 to the power of 6. Now, division is even more simpler. So you're just going to know multiplication is the addition of the exponent, while division, it's the subtraction of the exponent. So when we have 6 to the power of 5 over 6 to the power of 2, we're going to get 6 to the power of 3. Oh, sorry. However, when we have 6 to the power of 2, let's say over 6 to the power of 5, what do we do in this case? So, we're going to, instead of, the top minus the bottom, we're still going to do 5 minus 2, but instead, now it's going to be 1 over 6 to the 3, which is going to be 1 over 216 for those that wants to know the answer. And then we got to know about the power law, which is the power to a power. So let's say we have 5 to the power of, well, right here, they already gave us example, but 5 to the power of, let's say, 6. So essentially, you're going to times these numbers together, so that you're going to have 5 to the power of 2 times 5 to the power of 3, which is 5 to the power of 6. So we can calculate that the hard weight or whatever. So this is 25, and 25 to the power of 3 is obviously, what was 25 to the power of 3 of? I believe it was 15,625 or something. It was similar like that. So pretty easy. And then power of a quotient, we're talking about when we have something times something else to the power, we're actually just going to distribute this power to everything inside of the bracket. So for example, if I have 5 to the power of 5 times 2 to the power of 3, we're going to view this bracket as one thing. And then when we distribute it, we're going to distribute this thing, this power of 3, distributed to the 5 and the 2. So we'll end up being 5 to the power of 3 times 2 to the power of 3. And then this is even more simple. So when we have a power of a quotient, we're just distributing the power to the top and the bottom. So we have 2 over 2 to the power of 3 over 5 to the power of 3. Now we're going to get to some practices. Obviously, I keep on talking about this. I keep on emphasizing this in almost every single one of my math classes. That math is not a spectator sport. If you want to get good at math, you have to, somehow do it. You have to do some math. You can't just get away with it and be like, you know what? Mm, I just got away with it. No, that's not how it works. Okay, so, alright, let me just write. Okay, I can write. So, I'm gonna do a couple questions for you. One, I'm gonna do, wow, my pen is not working. I'm gonna do 1A. I'm gonna do 1A, which is multiplication. I'm gonna do B, that's division. I'm gonna do C. And that covers the few laws. Okay, so 1A, we have 4 plus 3, essentially. 2 to the, and that's gonna give us 2 to the power of 7, which is very easy. And then B, it's 2 to the power of 6. If you can't recognize it in that form, just rewrite it, and this is going to give you 2 to the power of 4. Now, remember that when your denominator, it's 0, it's 1 in this case. You're actually not dividing by anything. So Anything divided by 1 is itself. And then C was 2 to the 4 times 3, which will give you 2 to the power of 12. And then for those of you that did not learn this, but they definitely should have taught you this. So anything x to the power of 0 is always going to be 1. Alright, that stays true for no matter what you're dealing with. Surprisingly, I mean this really by surprise. 0 to the 0 to the power of 0 is actually still equal to 1. Which breaks some math rules that we understand, but you know what? It's math. So we don't quite understand how 0 to the power of 0 equals 1. But this is something you got to understand. This is weird, but it's true. So you gotta understand this. This is the two main takeaways you're gonna take away from today. And then I just evaluated that for you. I'm gonna do 2a, b, c again for you. So a will have 3 to the negative 2. So now we have to talk about negative exponents. So this is what I meant by, math is never a spectator sport. When you actually do it, you're gonna get used to it. So 3 to the negative 2. How do we get rid of this? We're going to make it equal to 1 to the 3 to the 2 to the power of 2. So instead of having this, negative exponent, we're going to do it 1 over. 1 over, and then we keep this entire thing, but we remove this to become 1 over. So now we can evaluate that, which is going to be 9. 1 over 9. Very, very simple. Simple math we're dealing with here. Sorry. And then I believe the rest is pretty straightforward from this, but I will still do it. B, C, B is 5 to the 0, which is just 1 again. And then C is 2 to the negative 4. Let me just clear this all up. Just clear all this up. Okay, so I fixed that issue. Now let's do, yeah, I was on C. I was on C. So negative 2 to the negative 4. This will become negative 2 to 1 over negative 2 to the 4. And remember, we have a bracket here, so that's going to become 1. So now, instead of, negative 2 to the power of 4, this is, if you don't have the bracket, you're going to evaluate this. But now you have the bracket, you're doing this. Because remember, when this negative, it could be a negative 1. It could be a negative 1 times 2 to the power of 4. That could be the case. So you just gotta keep being careful to always do the math and be careful. Take care of your math because it's very confusing, and I would have gotten a negative number if I didn't add the bracket, which is not good. And then obviously negative 2 to the power of 4 is 16. So 1 over 16 is the question for that. Clear the board. And then 3, we're simplifying. Basically, we're doing exponent laws, but we're just simplifying with variables. So a to the power of 7. B is, we're also multiplying that. B is 8. I believe you guys can handle some math. Simple math. We're in function, so I expect some, at least a little bit degree of math language there. So remember, when you have this, when you have to the power of nothing, that's actually to the power of 1. So now add them all up. That's going to be b to the power of 12. D. Now, people ask me, what happens when you have different things? This is what happens. They just get multiplied together. You just write them out like this. I mean, there's no way you're going to combine A and B together. Alright? I just want you guys to know, no matter what universe we're going to in, we're never going to combine two different variables together simply because we do not know the answer. We do not know what value they are. Now let's hop on to 4. This should still be very straightforward. This is A, and I'll not write that. B, and then this is M to the power of 6. C, this is, I'm gonna write this out because many of you seem to have problem was order of operations. So 4 minus -2. What is this? This is actually 6. T to the power of 6. So guys, please don't make these rookie mistakes. Really hurts me when I see you guys make these mistakes on the tests. And this is actually y to the -2, -5 minus -3. Please, guys, if you make some mistake like this, I'm gonna deduct extra mark. I've done that before. Okay, we're gonna do a little bit less of these because this is really easy. B. So remember, you're distributing the power, so you have a to the 2 times 4, 8. B to the 3 times 4, which is 12. And then C, you're just multiplying right there. There should be nothing wrong. And then that's 5. And 6, we're going to have x to the power of 3 over 2 to the power of 3, which is equal to x to the power of 3 over 8. And B, which is a to the power of 4 over b to the power of 4. C, x to the power of 10, y to the power of 15. So remember, you're actually still just multiplying this because you're distributing it. Be careful. There's nothing wrong with math. Just trust your math. Trust the process. You got it. 7. I'm gonna do A. I'm gonna do 4 questions for this because this is a little confusing because we have the numbering here. So treat them differently. 3 times 5, that's obviously 15. And M4 times M2, M6. Good. And then B will have -20. Just add the exponent up. A4 and then B6. And then C, we have an extra term, but that's okay. So negative minus negative times negative, that's going to give us a positive 6 times 5, that's going to be 30. And then A will have 1A, 2A, so A squared. And then B will have B squared and B cubed. It's going to give us B5. So I want you to treat all of these terms separately. You want to treat the numbers separately. You want to treat this separately. The A, you want to treat the B separately. Pretty straightforward. D, you're going to have 24 m to the power of 4 and n to the power of 7. Just treat all of these terms separately and you're done. And then 8, I wanna make sure I do one of these because I was looking at it and I knew somebody would make a mistake. So 2m3 squared. Some people just do 2m cubed and they're like, oh, it's over. But really, you have to apply this to the 2. This is a term as well, so this is actually 4m6. I've seen people make this even on calculus tests. Not the things I would expect, but okay. And I want to do one on G because it's a little different. So we'll have 4x squared. Remember to square this over 3y squared. It's never embarrassing to show extra steps, by the way, just so you guys know. It's never embarrassing to show extra steps. And right here, this is our answer. Never embarrassing to show this step where you're applying it to the top and bottom. Please don't be embarrassed to show steps. Some people in the class can do it in short amount of time and short amount of steps. That's because they probably took the course elsewhere. I know there's a bunch of math tutor outside. There's Olympiad, there's Kumon, there's all of this. Please just do your math and focus on yourself only. Don't care about other people. Never. I've learned after I care about other people, it's a horrible experience. A, we'll have 6 over anything to the power of 0 is 1 plus 1. Now, what is that? What is that? 6 over 2? 3. Thank you. And then you can have b to m to the -3 times 0, 0, into the 0. That's going to give you 1 over 1, which is 1. So remember that anything to the power of 0 is 1, and then I'll do a little more because why not? 1 over 4, because you're moving the negative exponent, plus 1 over 2 to the power of 3, which is 1 over 4 plus 1 over 8. And you guys can do this if you want. You guys can do the simplification, finding the lowest common multiple of this, and then you guys can add it. And that's pretty much it. I will continue to do more lessons of this around later.